Hi class, let's do this thing. Let's start chapter 7. First lesson, adjacent and vertical angles. We'll first review how to classify angles, and then we'll start to get into angle relationships. So, classification of angles, we have acute angles. Those are those angles that measure less than 90 degrees. There's an example there for you of what an acute angle might look like. Next, we have a right angle. That's when the angle measured equals 90 degrees. Usually, a right angle will have this almost like a red box in the corner, helping to identify that it's a right angle. Next, we have an obtuse angle. That's greater than 90 but less than 180. And then the last one we have is a straight angle. Exactly how it sounds. It's a nice straight line, straight angle, and that's equal to 180 degrees. So now that we have this reviewed, let's now get into how angles are in a relationship, how they relate to one another. So first we have adjacent angles. Angles are adjacent to one another when they share a common side and have the same vertex. So angles 1 and 2 are adjacent to one another. Angle 1 is also adjacent to angle 4. Adjacent means that they are next to each other. So when I think adjacent, I want to think next to it. Okay? Again, they share a common side and they have the same vertex. Reminder, vertex is where those lines, when they intersect, where they meet at. That black dot I just put there, that's the vertex. So if we're looking at angle 1, so I'm outline, this is angle 1 here. It is next to or adjacent to angle 2. It's sharing, see how I just went over the green, exactly where I went over blue, it's sharing that side, and they're both meeting at that vertex. Now 1 is not only adjacent to 2, but it's also, like I said, adjacent to angle 4. It's just sharing that other side. Okay, there's a handful of adjacent angles within this figure here. Next, let's talk about what if two angles are vertical to each other. So vertical angles are when they are opposite angles formed by the intersection of two lines. So in this figure, we have two intersecting lines. This line is crossing over, intersecting with this line. Forms 4 angles, and the angles that are opposite one another are vertical to each other. So I'm looking at angle 1, I'm going across the vertex to angle 3. They are vertical angles. The other pair of vertical angles are 2 and 4. So there are only 2 pairs here of vertical angles. They're across from one another. Real quick, I want to mention and review, you see those red arches within where it's showing the measure of the angle, like this right here. Oops. Those are showing that the angles are congruent, that their angle measure is equal or the same. So vertical angles are congruent, meaning they have the same measure. So 1 is congruent to angle 3. So whatever the measure of angle 1 is, it's also the measure of angle 3. Same goes for angles 2 and 4. They are congruent or equal. So when we see that word congruent, we want to think equal. Let's keep moving. So next, I'm going to go over, we're going to continue this lesson. Let's look at this first example here. We're naming angles using this figure shown to the left. Name a pair of adjacent angles and then also a pair of vertical angles. So we have 2 intersecting lines, this line FBC and ABD, and then we have this ray BE kind of just jetting off of those, okay? Now, a pair of adjacent angles. I'm looking at angles that are next to one another. So I just chose an angle to start with, and I chose ABF. So this angle ABF And now notice, I named it the way you would connect each point to form it. So the angle ABF, or I could have named it FBA, is adjacent to the angle ABC. So this angle ABC, they're next to one another. They're sharing the side AB, and then they're sharing that vertex B. They're next to one another. So if you notice, in yellow, I kind of highlighted over here when I wrote those, they're sharing that middle point B because that's their vertex, okay? Now, they're also sharing a side, and that side is AB. So you'll also notice that they both have AB when you write out the angle. And then the side that's different is that last letter there. So angle ABF and angle ABC are adjacent. Another thing I want to note real quick, just as a reminder, this symbol right here is how we show angle. You'd write it an angle sign, so that's identifying angle ABF. This again is my angle symbol, so I'm saying angle ABC. So just some reminders there of how to write an angle out. Next, I wanted to name a pair of vertical angles. Now remember, vertical angles are angles that are formed by two intersecting lines. So I'm looking at those intersecting lines and I'm looking what angles are across from one another. So again, I chose angle ABF to start. Now what angle is right across and they're only sharing a vertex? That would be angle DBC or CBD. Either way you say it or write it is fine. So angle ABF and angle CBD are vertical. They're across from each other. They're sharing that vertex B. So you'll notice they're only sharing one point in common, their vertex, their middle point. All right, let me go through these next two examples with you to show you and explain what I did, and then I'll let you review the last four on your own. So tell whether the angles are adjacent or vertical, then find the value of x. So I have this angle, it's giving me this angle that's 70 degrees right here. Now, I want to know what this x degree angle is. When I just outlined both of those, when I highlighted both of them, the only thing that overlapped was the vertex, okay? And they're crossing at the vertex. They're across from one another. So that's how I named that they are vertical. Now remember, vertical means they're congruent or equal. So if this angle measure is 70 degrees, then guess what? This angle measure is going to be 70 degrees. They're equal to each other. Let's look at example B. I have these two angles. I have a 31 degree angle, and then I have an x plus 4 degree angle. Together, they're forming a right angle, and it shows us that little red box in the corner showing us that they're forming a 90 degree angle. Now, these angles, if I were to kind of go over each one, 31 degrees, and then we have our x plus 4 degrees, they're sharing that side, and they're also meeting at their vertex. So these are adjacent angles, they're next to each other. Right? They're forming a right angle, which means it's going to equal 90 degrees. So this is how I came up with this formula or equation to help me solve for x. I know that together they have to equal 90 degrees, so I know that x plus 4 and the 31 degree angle has to equal 90 degrees. So I wrote that equation. That's going to help me now solve for x. So I combined my like terms to get 35. And now I'm going to solve to get x by itself. So I'm going to subtract 35 from each side. And that's how I got x to equal 55 degrees. Next, moving down our note sheet, we have these 4 examples at the bottom. Okay, it's our practice time. Now, I did tell the relationship. It wants us to tell whether the angles are adjacent or vertical. And then it wanted us to find x. So you can notice that I either set up an equation or I found out if they're vertical, they're congruent, so I just set them equal to each other. So what I want you to do is take a few minutes, pause this video, or I'm about to wrap it up anyway, and take a look at each of these examples, these 4 examples, and how I solved them, how I identified their relationship, and how I got a value for x. If you need to write down a few questions that you have, we are going to have a discussion about this. I am going to be available for Google Meet this week. So just write down any notes, anything that you're confused about, see if you understand how to identify adjacent and vertical and find the values of x. Okay, I look forward to talking to you guys. Let me know if you need any help at all.